In the coming lectures, we are going to talk about serialization. So first of all, what is serialization? Serialization is a mechanism of converting the state of an object into a byte stream. So the aim of serialization is to transform the objects into byte streams. Deserialization is the reverse process where the byte stream is used to recreate the actual Java object in memory. This mechanism is used to persist the object and to travel object states on the network. So we have the objects, so the instantiated Java classes. With the help of serialization, we end up with a stream of bytes that can be persisted into a file, into a database, into memory, whatever. Then deserialization is the process when we take the byte streams and convert them back into objects. So this is serialization, and the reverse process is the deserialization. Only the objects of those classes can be serialized which are implementing the java.io serializable interface. Serializable has no data member and method, so it is just a marker interface. It is used to mark Java classes so that objects of these classes may get certain capability. So this is the java.io serializable interface, and if we want to serialize a given Java class, then we have to make sure that given class implements the serializable interface. Let's consider some good to know things about serialization. During the serialization process, only non-static data members are saved, static data members are not. If you don't want to save the value of a non-static data member, you can make it transient with the help of the transient keyword, and that means it won't be saved via the serialization process. We are going to take a look at concrete examples and it's going to be clear. If a parent class has implemented the serializable interface, then child class doesn't need to implement it because serializable is going to be inherited. If a class has a reference to another class, all the references must be serializable, otherwise the serialization process will not be performed. In such case, not serializable exception is thrown at runtime. When an object is deserialized, the constructor of the object is never called, so it is extremely important that if we use deserialization, then we have to take it into consideration that the constructor of the objects are not going to be called. So this is what we are going to talk about in the coming lectures. Thanks for watching. In this lecture, we are going to talk about serialization and deserialization. So first of all, let's create a class, for example, car. The car class is going to be transformed into a byte stream, so this is why we have to make sure that this class implements the serializable interface. So as you can see, java.io.serializable, and first of all, we are able to add default serial version ID. As you can see, you can generate serial version ID, or you can use the default serial version ID. In this case, we are going to generate the serial version ID, and of course we have to save it. And as you can see, this is going to be the value that's going to identify the class we would like to serialize. So the serialization runtime associates a version number, this is the version number, with each serializable class called the serial version UID. So this is the serial version UID, as you can see, which is used during deserialization to verify that sender and receiver of the serialized object have loaded classes for that object which are compatible with respect to serialization. So if the receiver has loaded a class for the object that has different UID than that of the corresponding sender's class, then the deserialization will result in an invalid class exception. So this is why it is crucial to use serial version UID to be able to check whether the serialized object is the same as the deserialized object. Okay, so this is why we have to generate a private static final long serial version UID. By the way, if we do not specify this UID, it is going to work just fine. In this case, Java is going to generate a serial version UID on its own, but it is highly advisable to generate the private static final long serial version ID. Okay, so we have the serializable interface, we have the serial version UID, and we will have several field variables such as car brand, we will have the motor number, we will have the color, for example, and we will have a constructor. So in the car constructor, we get the car brand, we get the motor number, and we get the color, and we are going to set the car brand to be equal to the car brand. We set the motor number to be equals to the motor number, and we set the color to be equals to the color. I'm going to override the toString method as usual. So in the toString method, we are going to return with this dot car brand plus some spacing, this dot motor number, some spacing, and this dot color. Okay, so this is the class we are going to serialize. So in the application.java, first we instantiate a new car. It's going to be a Ford. The motor number is going to be something like this. And the color is going to be green. So what we have to do is we have to instantiate a file output stream. File output is equals to a new file output stream. And we have to define the file name, for example, serialization.txt. Okay, so with the help of the file output stream, we are able to transform an object into a stream of bytes. Of course, we have to use a try-catch block. Instead of a file not found exception, we are going to catch all IO related exception. Okay, so we use something like this. Then we use an object output stream. So object output stream is a new object output stream, and we have to define the file output. And then we are able to use this object output stream in order to serialize the given object. So we write object and we have to define the car. So this is how we can serialize a given object. Then we have to close the stream. So object output stream dot close, and we have to do the same with the file output as well. So that's all about the operations as far as serialization is concerned. So here we print out that the car object has been serialized. Okay, so if we save and run the application, car object has been serialized, which means that if I navigate to the folder, I guess it is the advanced Java, Udemy serialization.txt, as you can see. So this is the file I am looking for. If we double click serialization.txt, of course it is not a human readable file, but this file is going to contain all the information that needed for Java in order to deserialize the given object. So the given car object is present in this file. Okay, so how to deserialize the given object? I'm going to use a try-catch block. So let's use deserialization. And here I'm going to paste it. And instead of a file output stream, we will use a file input stream. So file input stream is a new file input stream. And we have to specify the txt file. So serialization.txt. Then we have to use an object input stream. Okay, object input stream is a new object input stream, and we have to define the file input stream as the argument. And then we are able to read the given car. So it is the serialized car is equals to, we have to make some casting, and object input stream dot read object. Of course, there's an unhandled exception, class not found exception, so I throws a class not found exception here. Anyways, we have to print out car object has been deserialized. I'm going to close file input stream and I'm going to close the object input stream as well. And here I'm going to print out the deserialized car. So if I save it and run it, as you can see, we have managed to serialize, so save the given object, and then we have managed to deserialize, so load the given car object. And as you can see, these are the parameters: Ford, this is the model number, and this is the color. What we have been talking about in a theoretical section, that we are able to prevent some variables to be serialized. So if we use the transient keyword, so string transient color, then the color is not going to be serialized, which means that if we save the application and run the application, as you can see, the color is a null. So with the help of the transient keyword, we are able to notify Java that we don't want to serialize, so we don't want to store this value as far as the color string is concerned. So that's all about the transient keyword. And what's crucial, that if we have a new class, for example, Ford is a car, so we can say that Ford extends the car, because car is a serializable. This is why Ford as a class is going to be serializable as well. So we add the constructor like this. For example, I define another variable string Ford type, and here we get another string, so string Ford type. This Ford type is a Ford type. Okay, so let's create a Ford instead of a car. So I'm going to create a new Ford, and for example, the type is going to be Focus. So it's going to be a green Ford Focus. So if I rerun the application, it is going to work just fine. Okay, just to make sure it is working fine, let's define another value. So if we rerun the application, as you can see, it is working just fine. What's crucial, that if we create a given class Ford that extends a given class that implements the serializable interface, then there is no need to make sure that Ford implements the serializable interface, which means that the conclusion is that all the subclasses are inheriting the serializable interface. So that's all about serialization and deserialization. Thanks for watching. In this lecture, we are going to talk about Lambda expressions and functional interfaces. So first of all, what are Lambda expressions? A Lambda expression was added after Java 8, and it is a block of code that gets passed around like an anonymous method. It provides a clear and concise way to represent single method interface using an expression. You can use Lambda expressions only with functional interfaces, so interfaces that contain only one abstract method. What are the advantages of Lambda expressions? First of all, Lambda expression is a function that can be created without belonging to any class. So these expressions are independent of any classes, which means less coding. And finally, Lambda expression can be passed around as if it was an object and executed on demand. So these are the main advantages as far as Lambda expressions are concerned. Let's take a look at the syntax. We have optional parameter types. In this case, we have string s1 and string s2. S1 and s2 are the parameter names. We have the arrow operator, and we have the body itself. In this case, when we return s1 plus s2. This is the syntax including optional parts. Optional parts are the curly braces, for example. So after omitting optional parts, we end up with something like this: s1, s2, arrow operator s1 plus s2. In the next lecture, we are going to talk a lot about Lambda expressions, so it's going to be clear. What about functional interfaces? A functional interface is an interface that contains only one abstract method. They can have only one functionality to exhibit, and Lambda expressions can be used to represent the instance of a functional interface. We have to use this annotation functional interface. It is an interface, so this is why we have to use public interface concatenate, and then we can use a public string concatenation with the parameter types, in this case strings, parameter names text1 and text2, and as you can see it is an abstract method without a body, of course because it is an interface. So this is called a functional interface. Let's talk about predefined functional interfaces. As you will see in the next lectures, you can define your own custom functional interfaces, but useful to know that Java provides predefined functional interfaces as well to deal with functional programming by using Lambda and method references. These predefined functional interfaces are placed in java.util.function package. Of course, you can take a look at the documentation on the website of Oracle as usual, and in the coming lectures we are going to talk about Lambda expressions and functional interfaces. Thanks for watching. In this lecture we are going to talk about Lambda expressions. So let's take a look at a concrete example what to do if we don't want to use Lambda expressions. So for example, I'm going to create an interface sum. And within the interface, I'm going to have a public integer odd method that's going to sum up two integers, the integer num1 and integer num2. So what we can do is to use a so-called anonymous inner class. So sum is equals to a new sum, and as you can see we can instantiate this interface as an anonymous inner type. So we have to define what to do as far as the odd method is concerned. We are going to return num1 plus num2. Okay, so we can do something like I print out that the sum interface odd, for example, 10 and 5. So if I save it and run it, the solution is going to be 15. So this is how we can use interfaces. We define a given method, and in the application.java class, we create an anonymous inner class. We define the concrete behavior, and then we can use this method without any issue. So what to do if we want to use Lambda expressions? With the help of Lambda expressions, there is no need to use anonymous inner classes and so on. So it is way better and way easier to use Lambda expressions. So what we can do that instead of instantiating the given interface as an anonymous inner class, we can use something like this. The sum is equals to, and we have to define the parameters integer num1 and integer num2. We have to use the arrow operator, and then we have to use something like this, num1 plus num2, like this. But of course, because in the sum interface we return with an integer, this is why we have to define the return keyword as well. Sorry for that, of course, without any typo. So this is how we can use a Lambda expression. As you can see, we have to define the arguments because the sum interface odd method has two parameters, the number 1 and the number 2, and these parameters are integers. So this is why we have to define integer num1, integer num2, and then we have to use the arrow operator, which is a fundamental operator of Lambda expressions, and we have to define what to do. Basically, this is how we define the behavior itself. So whenever we have two integers, then we would like to return with the sum of the two integers. Okay, again, we can use something like this, .odd 10 and 20, for example. So we can use the given interface in the exact same manner, and the result is going to be 30. So we are able to sum up the values with the help of this Lambda expression. What's crucial that we are able to simplify the original syntax and we can omit optional parts. So as you can see, for example, we don't have to define the parameter types because Java will know for certain that these are going to be integers because in the interface the odd method is dealing with integers. So for example, we can get rid of these and we just have to define num1 and num2. And we can use something like this. We don't have to define that return num1 and num2. We can use something like this. So as you can see, it is working fine. Maybe it is not that straightforward at what's happening under the hood, but after you are using lambda expressions for a while, then it's going to be clear that in this case, num1 and num2 have something to do with the parameters, and we don't have to define that they are integers because Java will know it for certain based on the given method. Then with this operation, we define what to do as the behavior. So we get two integers and we return with the sum of the given integers. So if I run it again, then it is going to work fine. For example, with different integers, as you can see, the result is 60. So this is how we can use lambda expressions. I'm going to create another interface, for example, greeting. In the greetings interface, we will have a public void. So in this case, we do not return an integer. It's going to be a public void. Say hello, for example. So let's save it. Again, we can use something like this, that the greetings is equals to an empty parameters. Why? Because in this case, there are no parameters of the given method. As far as sum is concerned, we had two parameters. As far as the greetings say hello method is concerned, there are no parameters. So this is why we have to use an empty parameter list. And what do we want to do? We would like to print out that hello word via lambda expressions. So if we save it, of course, we have to use greetings.sayHello. And if I save it, then as you can see, it is going to work fine. So what's happening in this case? We have to notify Java that there are no parameters as far as sayHello method is concerned. It is void, so there is no need to return anything. And basically the behavior, so the body of this method is going to do something like this. It's going to print out hello world via lambda expressions. Okay, if this sayHello method has a given string argument, for example, the message itself, if I save it, then of course it's not going to work fine. In this case, because there is just a single parameter, we can use the name, for example, string or whatever you want. So this variable is going to represent the string parameter here. It can be a message, it can be as, it can be string, whatever you want. For example, MSG stands for message, is going to work fine. And then we print out hello world and we append the message. So if I save it, and here we can define, for example, the message itself. So this Java string is going to be the message, and this variable is the same as the string message. So this is how we can inject a given string parameter. So if we run it, hello world Java, or for example, useful lambda expression. And this is how we can print out hello world and then useful lambda expression because we use this string. This string is going to be the message that's going to be appended to the hello world string, and this is how we can use lambda expressions. Thanks for watching. In this lecture, we are going to talk about functional interfaces. So any interface with a single abstract method is a functional interface basically, and its implementation may be treated as lambda expressions. So why do we prefer functional interfaces? Because we can use it for lambda expressions. But the interface may contain other methods such as static methods or default methods. So what's crucial that a functional interface has to have a single abstract method, but there may be as many static and as many default methods as we want. What's crucial that there are predefined functional interfaces we are going to talk a lot about in this lecture, such as the consumer, predicate, unary operator, supplier, and so on. So first of all, let's create a functional interface. I recreate the sum interface, and as we have discussed in the theoretical section, we can use the functional interface annotation. Okay, there's going to be a compile time error because the sum interface is not a functional interface. Why? Because every single functional interface has a single abstract method. So in this case, we have a public integer odd, integer num1, and integer num2. If we define this abstract method, as you can see, the error message is gone. Because we have a single abstract method, this is why it is a functional interface, which means that we can use it for lambda expression. But because there are other interface related methods, such as the static void static method, for example, as you can see, it is going to work just fine. Okay, sorry for that, we have to define the body. So this is a static method in the interface. Anyways, what's crucial that we can define as many static methods and default methods as we want. What's crucial that a functional interface has a single abstract method, and we can use it for lambda expressions. So we have the sum, we can define the num1 and num2, and what do we want to do? We want to sum up the values num1 plus num2. So in this case, we can print out, for example, sum odd 10 and 12, and the result is, I guess it's going to be 22. Yeah, it is working fine. So we can use a functional interface with lambda expressions. And let's take a look at the predefined functional interfaces one by one. So first of all, let's talk about the consumer functional interface. The consumer interface represents an operation that accepts a single input argument and returns no result. So it consumes a given parameter without returning any value. For example, when we get a given string and we print out that given string in a lowercase manner. So we get Java programming step by step from A to Z, and it is going to accept that given string and performs that given operation we define. What is the operation? That first of all we convert all the letters to lowercase letters, and finally we print out the solution. So if I save it and run it, that's why 22 is going to be the sum of 10 and 12. Then Java programming step by step from A to Z. As you can see, we have managed to transform all the letters to lowercase one. So this is when we can use a consumer. Consumer accepts a single input and returns no result, because we just do some operation without returning a given result. Okay, what about predicate? Predicate interface represents a predicate, so Boolean valued function of one argument. So for example, we would like to check whether a given input is greater than 10 or not. This is why we create a predicate integer. We have the a parameter, so basically this is the input, and what do we want to do? We want to check whether this a parameter is greater than 10 or not. So we can call this predicate.test. This test is going to evaluate this predicate on the given argument. So this is why it is true, because 11 is greater than 12. But what if we specify 5? In this case, 5 is smaller than 10, so this is why we get a false. So this is when we can use predicate. Let's talk about the unary operator. It represents an operation on a single operand that returns a result of the same type as its operand. So for example, we would like to have an input and we would like to transform the input to uppercase letters. So for example, we have that string hello Java, and we would like to consider all the letters and converts them to uppercase characters. So this is why we can use a unary operator, and the string.apply with the help of the apply method, it is going to apply this function to the given argument. So this is how we can define a unary operator. Okay, then what about a supplier? It represents a supplier of results, so the supplier can be used in all contexts where there is no input but an output is expected. So in this case, there is no input. This is why the input list is empty and the output list is a random value. So this is why, as you can see, the random value is 0.54908 and so on. So in this case, with the help of the supplier, we can handle situations when there is no input but an output is expected. In this case, random value.get, this get method is going to get the results without an input. There is no input, the output is a random value within the range 0 and 1, by the way. Okay, so that's all about supplier. What about function? It represents a function that accepts one argument and returns a result. So in this case, we can define the behavior itself, that the function string is going to be a function example. The input is a string, and then we would like to return and call a given function with the given argument. In this case, this function is going to return hello, plus it is going to concatenate the given string, but this is what we can do with the help of function. Function accepts one argument and returns a result accordingly. Again, we can call the apply method in order to apply this function to the given argument. So that's all about functional interfaces. We can create functional interfaces with the help of functional interface annotation. We just have to make sure that we use a single abstract method, and there are several built-in functional interfaces we can use with Lambda expressions. Thanks for watching. In this lecture, we are going to talk about method references. Okay, so we can use Lambda expressions to implement functional interfaces as we have seen in the previous lectures, but Lambda expressions are not the only mechanisms we can use for this purpose. Sometimes a Lambda expression does nothing but call an existing method. In those cases, it's often clearer to refer to the existing method by the name, and this is why method references came to be. Method references enable you to do this. They are compact, easy to read Lambda expressions for methods that already have a name. So basically, method references are not independent of Lambda expressions. In other words, a method reference is the shorthand syntax for a Lambda expression that executes just one method. What's extremely crucial that method references always utilize the double colon operator. Okay, so there are four kinds of method references. Reference to a static method. The syntax is that we have to use the double colon operator containing class colon static method name. So this is how we can deal with the method reference as far as static methods are concerned. A reference to an instance method of a particular object. In this case, we have to use the containing object, double colon again, and instance method name. So it is very similar, as you can see, and the syntax always contains the double colon operator. What about reference to an instance method of an arbitrary object of a particular type? In this case, we have to use the containing type, double colon operator, method name. As far as reference to a constructor is concerned, we have to use the class name, the double colon operator, and the new keyword. We are going to talk a lot more about concrete examples, and it's going to be clear. So here are some examples for Lambda versus method reference solutions. The results are the same, but in many cases the method reference solution has easier syntax. So for example, we can calculate the length of the string with the help of Lambda expression. String, the arrow operator, string.length is the same as string double colon operator length. We can call the substring method with Lambda expressions, and we can call it with method references. We can call replace all method with Lambda expressions, and we can do the same with method references. So as you can see, it is more convenient and easier to use method references. However, we can't use method reference to replace all kinds of Lambda expressions since they have some limitations. We will see examples of these in the following lectures. Until then, the golden rule that needs to be remembered is that if the task can be accomplished with both methods, then use that which is more readable in that case. As far as I am concerned, I am a huge fan of method references. In the next lectures, we are going to talk about the concrete examples. Thanks for watching. In this lecture, we are going to talk about method references. So as we have discussed in the theoretical section, there are four kinds of method references. A reference to a static method, a reference to an instance method of a particular object, a reference to an instance method of an arbitrary object of a particular type, and reference to a constructor. So this is what we are going to talk about on a one-by-one basis. So first of all, let's create a functional interface. In one of the previous lectures, we have been talking about functional interfaces, and a functional interface is basically an interface with only one abstract method. So we can create an interface. So interface, functional interface. Okay, I'm going to get rid of the typo, and here we will have a public void show method. So this is the only abstract method, and this is why this functional interface is basically a functional interface. So let's take a look at a concrete example as far as the first point is concerned, so a reference to a static method. First of all, let's create the static method itself. I'm going to create a public static void static greeting, and it is going to print out that greeting from a static method. So what we can do in this case is that the functional interface is equals to an application static greeting. So as you can see, it is going to work just fine. The application is the class itself, and as you can see, the static method static greeting belongs to the application class. So this is why we can do something like this, that application static greeting. And what does it mean exactly? That whenever functional interface dot show, so basically whenever we call the functional interface show method as we have defined here, then it is going to be printed out because we use the application double-colon static greeting. So if I save it and run it, greeting from static method. So this is how we can use a reference to a static method. Let's talk about the second case. So a reference to an instance method of a particular object. So first I'm going to instantiate the application class. So we have a new application. Let's create not a static but an instance method. So public void instance greeting. And I'm going to print out that this is a greeting from an instance method. So in this case, what we can do is that functional interface 2 is equals to the application double-colon instance greeting, as you can see. So in this case, the functional interface is the same functional interface with the public void show method. So whenever we call the functional interface 2 dot show method, then this instance method is going to be called because we use application double-colon instance greeting that's pointing to this method. So after instantiating the application class, we can use something like this. So if I save it and run it, this is a greeting from an instance method, as you can see. By the way, we can do the same with the help of the new keyword, so new application like this, and it is going to be the same. So if I get rid of the object itself, I save and run it, it's going to be the same. So we can use this anonymous instantiation, the double-colon and instance greeting. This is the method that's going to be called whenever we call the show method of the functional interface. Okay, let's take a look at the third example. I'm going to create a one-dimensional array of strings. Names, for example. We have Kevin, we have Alan, we have Adam, we have Joe, we have Kate, and what we can do is that we can sort the one-dimensional array of names, and here we can specify a lambda expression with the help of method references. So string double colon and compare to ignore case which means that it compares two strings lexicographically, ignoring case differences. So we don't care whether the given character is an uppercase letter or a lowercase letter. So this is how we can use the so-called method references, as we have discussed in a theoretical section. So we can print out the arrays.toString, and we specify the one-dimensional array of strings. Then we save it and run it, and as you can see, this is the sorted order: Adam, Alan, Joe, Kate, and Kevin. So this is how we can use method references: the string, double colon, compare to ignore cases, which is a method, as you can see. Okay, so this is an example for the third case. So when there's a reference to an instance method of an arbitrary object of a particular type. This is a one-dimensional array of strings in this case. And then we can use the reference to a constructor. So I'm going to create a new class, message class, for example. The message class is going to have a constructor. So within the constructor, we get a string, and then we are just going to print out that given string. So this is what the message class does. Okay, in the application, we have to create a new interface. So again, we create a functional interface 2, which means that it is a functional interface with one single abstract method. In this case, it is going to return with a message class, and the name of the method will be showMessage with a string. This is the single abstract method as far as this interface is concerned. So we can use something like functional interface 2 is interface 2, for example, and we can call the message class double colon new. What does it mean exactly? That we call the constructor of the message class. The message class constructor is going to get a string, and it is going to print out that given string. So whenever we use the interface2.showMessage and we specify a given message, this is a message, then this string is going to be printed out, because as far as the new keyword is concerned, we call the constructor of the message class on a given string and we print out that given string. And because we specify this is a message, so this is the string basically, it is going to be printed out. So whenever we run it, as you can see, this is a message is going to be printed out. So this is how we can deal with method references as far as static method is concerned, instance method is concerned, instance method of an arbitrary object is concerned, and reference to a constructor is concerned. Thanks for watching. In this lecture, we are going to compare lambda expressions and method references. So I'm going to create an interface sum, and here we are going to have a public void addition with integer num1 and integer num2. So this is a single abstract method, which means that it is a functional interface. Okay, so what we can do as usual, that the sum is equals to num1 and num2, and we are going to use the add method. So in this case, we call a given method, and let's create that given method. So I'm going to create this static integer num1 num2, and we return with num1 plus num2. So if I save it, and we just have to call the addition with 10 and 11, for example, then of course the result is going to be printed out. Okay, so the result should be 21, of course. Yeah, sorry for that, there's going to be an error message because the sum is going to return an integer, of course. So if we go back to the application, it is working fine. So this is a lambda expression that we have two arguments as we specify here, and with these two arguments we are going to call this static method integer1, integer2, and we return the sum of the two integers. That's why it is going to work fine. The result is 21. Okay, so this is how we can use lambda expression. But how to use method references? In this case, we can say that sum2 is equals to the application dot odd, because this odd is a static method. This is why we can refer to it via the application class. So we can use something like this. This is what we have been talking about in the previous lecture. So we can print out again the sum2 dot addition, for example 5 and 10. And of course the result should be 15, which means that it is working fine. So as you can see, maybe using method references is a bit better option because it is more compact than this lambda expression. So this is why I like method references. Okay, if we create another method, for example increment, and in this case we have a given value, this integer num, we return with the number, but before returning the number we are going to increment the value. So for example the number plus 10. So in this case, if I save it, we can use something like this, and this is the main advantage of lambdas, that we can chain operations, while on the other hand we are not able to create complex operations with the help of method references. So in this case I am able to create something like this. The sum3 is equals to, I specify two integers, and first of all we add the given integer, and before that we increment the value of the second argument. So as you can see, we are able to use two operations at the same time. We are going to add the first parameter and the incremented value of the second parameter. So if I print out the sum3 dot addition, for example 10 and 15, and what's going to happen? We are going to add 10 plus the incremented value of 15. 15 plus 10 is 25, so the result is going to be 25 plus 10, so 35. So if I save it and run it, as you can see, the result is 35, which means that we are able to chain operations basically, and this is the main advantage of lambdas, because we are not able to do the same with method references. So we are not able to call both methods at the same time with the help of the colon operator. So we are not able to do something like this dot add, and we specify some integers and then another colon increment, and so we are not able to chain operations with the help of method references. And this is why if the given operation is very simple, then we are able to use method references. But if we are after a more complex operation, such as operation chaining, then we have no other option but to use lambda expressions. Thanks for watching. In this lecture, we are going to talk about for each loops with lambda expressions and with method references. So after Java 8, the for each loop provided programmers with a new simplified way for iterating over a given collection. This collection can be an array list, it can be a hash set, it can be a map or anything else. So let's take a look at a concrete example. I'm going to create an array list of strings. For example, names is a new array list. Of course, we have to import the java.util.list. Okay. And I'm going to add several names, such as Adam, such as Kevin, Natalie, Joe, Brad. Okay, just for demonstration purposes, it's going to be fine, and we can use for each loop without any problem, because this array list stores strings. We can use string s and names, and we can print out the string itself. So we iterate through the names one by one and we print them out. So if we run the application, of course, Adam, Kevin, Natalie, Joe, and Brad are going to be printed out. But we can use lambda expressions. So we can do something like this: names for each, and we have to define the lambda expression because this list stores strings. This is why we are going to reference the names with the variable s. And what do we want to do with these variables? Of course, we want to print them out. So this is what we can do, and if I save it and run it, it is going to work just fine. So of course, feel free to change the variable name. It is not that crucial. You can use name, and in this case the name is going to be the variable for the given string names. Of course, you have to make sure to be self-consistent, so in this case again it is going to work just fine. So this is how we use lambda expressions in order to iterate through all the values in a given collection. We can use method references as well. So we can use names.forEach again, and what do we want to do? We want to do system.out, and we want to call the println function on every single item of the list. So that's all we have to do. If I save and run it, as you can see, it is going to work fine. So this is what we have been talking about, that as far as a method reference is concerned, we have to use the double colon operator. In this case, we iterate through the given array list of strings. This is the names as far as a for each loop is concerned. And what do we want to do? We want to call the println method, which means that we want to print the values one by one. We can do the same with a hash set. So if I create a set of strings, set is equals to a new hash set, and I would like to use arrays as list, and here we can define the given items. So this is the item 1, we have the item 2, we have item 3, and so on. So in this case, we create an array of strings, and this is what we are going to transform into a hash set. So if we import hash set and we import java.util.set, then it is going to work just fine. And again, we can use the set.forEach, and we have to define what do we want to do. Of course, we want to print out the given items, so system out println s, and if I save and run it, it's going to work just fine. Of course, we can use again method references. So system.out and the println function we want to call. So if we run it, it is going to work just fine. Let's take a look at hash maps. So if I create a map with string keys and integer values, it's going to be a new hash map. Of course, we have to import the java.util.hashmap and the java.util.map. First of all, let's rename it to map, and I'm going to put some values. So A is going to have the value 10. Okay, then for example, B is going to have the value 20. Then C is going to have the value 30. And again, we can use lambda expression in order to consider all the values of the map. So as far as the original for each loop is concerned, we have to use something like this. The map.entry is a string and integer as far as the keys and the values are concerned. It is the entry, we get the entry set, and here we are able to print out the entry.getKey plus some spacing and the entry.getValue. So this is how we use for each loop in order to consider all the key value pairs in a hash map. If I save and run it, it is going to work just fine. So how to use lambda expressions in order to achieve the same goal? We can use map.forEach. We have to define the parameters, so key and value, because the given map has a key parameter and a value parameter. And what do we want to do? We want to system.out.println the key, some spacing, and the value itself. So this is exactly what we want to do, and if I save it and run it, it is going to work just fine. So as you can see, it is way better solution than the original for each loop. We have the key, we have the value, so these are the key value pairs, and what do we want to do? We want to print them out, key and the values accordingly. Is it possible to use method references? As far as method references are concerned, we are not able to use something like this, that system.out double colon operator println. It's going to be an error message because the type printstream doesn't define the println for strings and integers. So here we have two parameters, and we can use method references in cases where the lambda expression body only contains a call to one single method. But since there are two implicit variables, key and value, so a string and an integer, we cannot use the below code to call println method of system.out class. So this is what we have been talking about as well in the previous lectures, that I am a huge fan of method references, and I guess that it is way more convenient than lambda expressions, but the main disadvantage of method references that sometimes we are not able to use it. So we are not able to transform all lambda expressions to method references. Thanks for watching.